So this question is a translate word problem question. So all that means is we want to write down any quantitative information as we read it so that we don't have to come back at the end and reread the question. So the first sentence in this question says the population in millions of Suzhou, China can be modeled by the function, right? So I'm going to write that down. P of t is equal to 1.1 times 1.066 to the t power. That is the population in millions, where t represents the number of years after 1990. Okay, number of years after 1990. T is years, I'll just say greater than 1990. And we know that t is between 0 and 25, right? So I'm not going to write that down, but I'm going to box it so that I know where that is quickly. Which of the following equations best models a population in millions of Suzhou? Okay, well, we know this models the population of Suzhou, China in millions. So what's going on? Which of the following equations best models the population in millions of Suzhou, where n represents the number of years after 1995? Okay, so, and n is between 0 and 25. So what's happening here? What is happening? We're given this function, this model for the population of Suzhou, China in millions. But then we're asked to replace that with a new model, a new equation, where n represents the number of years versus t representing the number of years. So t is years after 1990, n is years after 1995. Yes, after 1995, it says. So that tells me that t is equal to n plus 5, right? When n is 19, so let's say when n is 19, so when the year is 1996, let's say, right? In the year 1996, t would equal 6, right? Because that's 6 years after 1990. And n would equal 1, because that's only 1 year after 1995. So that proves that this relationship, right, that t is equal to n plus 5, that's the relationship between n and t, right? And you can choose another number. You can choose year 2000, the year 1998, and you'll find that this relationship is maintained. T is equal to n plus 5. So how do I convert this t to n plus 5? Well, I just simply write it, right? So my r of n, which obviously is what we're looking at. I don't know where r came from. It's not mentioned in the question. But given the answer choices, it must be, what we're looking for population. So r of n should equal 1.1 times 1.066 to the n plus 5. That should be our answer, right? Because we're only replacing t with its n equivalent, which would be n plus 5. So where's our answer? So choice A is saying we're replacing t with 5 times n. So that's not correct. Choice B is saying we're replacing t with n minus 5. So that's also not correct. Choice C does something a little weird, right? We have 1.066 to the 5th and then 1.066 to the n. And what we have to keep in mind is that when you simplify that, that is equal to 1.066 to the n plus 5. Here's how we know, right? So again, if you recall our exponent rules, I'll use x squared times x to the 3rd. We know that that's going to be equal to x to the 2 plus 3, right? When you're multiplying the same base that has exponents, you add the exponent. So that's exactly what we're doing here. Same base, 1.066. We have exponents on each of those bases, so we just add them. So that means that C, choice C, is the correct answer because it matches our expectation here, which really came from the original question, right, the original information, just replacing what t is with regard to n. So hopefully that all makes sense. Choice D is gone because of this 5 here. That should not That should not be there. We don't need a fifth power on the 1.1. So choice C, all it did was break down this n plus 5 power into a 1.066 to the fifth times a 1.066 to the n. But same answer. So choice C is correct.